The object, now officially named 3I Atlas, is believed to be up to 12 miles wide.
Shocking, impossible, real. NASA has officially admitted that the interstellar object 3I Atlas might be bending solar winds with its own magnetic field. For years, science told us only massive planets could pull off such a cosmic shield. But now, something the size of a fragment has shattered that rule. Was this a glitch in the instruments, a new force of nature, or something far stranger? In this video, we dive into the evidence, the panic, and the unanswered questions surrounding 3I Atlas. Because once you see the patterns, you'll never look at the solar system the same way again. The impossible announcement. When NASA makes an announcement, the world usually braces for dense technical jargon or cautiously worded updates. But on April 17, 2024, a single line in their release sent shockwaves far beyond the scientific community. The statement read, "Unusual magnetic features detected in the vicinity of 3I Atlas. Further analysis ongoing. Clinical, reserved, and almost sterile in its delivery." Yet those few words carried an earthquake of meaning, because in plain English, NASA was admitting that a comet-sized interstellar object might be bending the solar wind, something no fragment of rock and ice should ever be capable of doing. The timing was crucial. Within minutes of the release, journalists, astronomers, and even late-night hosts seized on two phrases that rarely make primetime headlines: magnetic field and solar wind. Normally, these terms belong to specialists buried in plasma physics papers. Suddenly they were everywhere, ricocheting across news tickers and social feeds. And for good reason. What NASA hinted at wasn't a minor curiosity. It was a direct challenge to one of space science's bedrock rules. Only massive planets with molten cores, spinning fast enough to act as dynamos, were thought to carve out a shield against the sun's relentless stream of charged particles. Earth, Jupiter, Saturn, these giants could stand their ground, but a body only a few miles wide? Impossible. Within NASA's own ranks, the disbelief was almost palpable. Dr. Richard Kowalski, whose team first flagged the anomaly, typed out a message that would reverberate throughout the worldwide astronomy community. Anyone seeing this in the mirrored logs? This shouldn't be possible for a body this small. There was in this sentence the crack of a lifetime's worth of certainty. It was one thing to bend solar wind. It would be entirely another violation of physics in itself. As the data confirmations rolled in, the tension became almost tangible. Veteran heliophysicist Dr. Christina Cohen, who had worked with the Parker Solar Probe, recorded in her laboratory journal that Atlas had a magnetic signature like some minor planet, not a comet. Unusual, to say the least. Not just weird, but unprecedented. Suddenly, the floodgates opened as data requests poured into her inbox from colleagues and government offices alike, all clamoring for raw data, calibration files, and error checks. Could it actually be real? Any chance at all that the reading could have been fabricated, caused by a bug, or just a good old magnetometer glitch? Skepticism ruled for 48 hours. Backup instruments were fired up at a number of ground stations. Data were mirrored, reprobed, and reanalyzed. Little by little, doubt began to fade away. This was not going away. The anomaly was stubbornly reproducible. The chances of one of the instruments being out of order dropped to near zero. All of the logs were lined with Atlas's path across the ecliptic. This had caught the attention of NASA. This cannot be considered an outlier. This is evidence that poses ugly questions about how little we really know. Its cultural impact was instantaneous. Comet with a force field had electrified the tabloids. Talk radio was torn apart by speculation over alien technology. Meanwhile, an honest effort by the science community at damage control was being attempted by trying to inject a little caution into this frenzy. By this time, damage, or rather inspiration, had done its job. For the first time in decades, solar wind and magnetic fields made it to the front pages, and it wasn't just a problem in astronomy. Rather, this was a story placed right at the heart of our cosmic rulebook, and that's exactly when 3 spacecraft, scattered millions of miles apart, recorded something that changed the debate forever. 3 probes, 1 anomaly. The scientific world thrives on evidence, not headlines. One press release might shake the public, but among researchers, data is king. And that's exactly what arrived on August 18th, 2024, at precisely 8:03 UTC. 3 separate spacecraft, positioned in vastly different corners of the solar system, each caught something extraordinary in their instruments. On their own, any one of these readings might have been dismissed as background noise or a glitch, but taken together, they told a story too precise to ignore. First came SOHO, the Solar and Heliospheric Observatory stationed at the L1 Lagrange point between Earth and the Sun. Its plasma sensors detected a bow-shaped disturbance in the solar wind, a ripple that shouldn't have been there. Normally, such a disturbance only appears downstream of planets with strong magnetic fields, like Earth or Jupiter. Yet this one was perfectly aligned with the trajectory of a tiny interstellar body, 3IATLAS. The timestamp was locked, 0803 UTC. It was a qualified probe 2 minutes later. Very different from the earlier probe was the NASA Parker Solar Probe, which effectively deep into the Sun's corona, measuring a sudden increase in local magnetic field strength. Not a tiny variation, but a spike, a clean signal. Standing out from the usual solar readings clutter, Parker's magnetometer outlined a gradient shift right across the predicted flight path of Atlas. Time, 0805 UTC. Then came a deflection event roughly 6 minutes after the SOHO readings, with other third evidence being contributed by MAVEN, now in orbit around Mars. Its high-energy detectors registered a deflection event, solar particles shifting their path in a manner which were nominally unrelated to the solar output or the weak magnetic influence exerted by Mars. The coordinates, yet again, pointed back to the Atlas. Now, it was 8:11 UTC. 3 spacecraft, 3 vantage points, 1 aberration. Almost no chances exist for such a coincidence. Different instruments, made by different teams, millions of miles apart, all recorded the inflow of some phenomena within minutes of each other. Upon checking the mirrored logs, the data matched with eerie precision. Or simply, Dr. Richard Kowalski told his team, "This isn't a glitch." The Heliophysics Division of NASA, wasted no time. On an emergency call, mission leads from SOHO, Parker, and MAVEN, alongside JPL's Chief of Data Science, dialed in. The agenda was simple: to find out whether or not this was real. By 9:15 a.m., the assembled parties had arrived at a sobering consensus. There was no solar flare, no coronal mass ejection, and no background interference implicated in this event. This disturbance was physically associated with the path of Atlas, a Level 1 anomaly in NASA speak, that is, reserved for discoveries that clash with existing models.
Space exploration happening in La Cañada, Flint Ridge.
SkyCal's Desmond Shaw is over the historic Jet Propulsion Laboratory.
The action was taken within minutes and classified. After 90 minutes, a report was drafted with an overlay of readings to be sent to the White House for approval. The technical justification, meanwhile, painted a different picture. SOHO's plasma bow, Parker's magnetic spike, MAVEN's particle deflection, all right in their synergy directing towards Atlas. No solar storm, no planetary interference, just a comet-sized object and a solar wind bending in hitherto unrecorded fashion. Because when rules collapse, explanations rush in, and not all of them agree on what Atlas really is. The clash of explanations. Evidence was one thing, explaining it was another. Within days of the triple-confirmed anomaly, scientific circles fractured into competing camps. Everyone agreed that 3IATLAS had triggered readings no comet should produce, but the agreement stopped there. The real battle was over why. At the Jet Propulsion Laboratory in California, the mood was cautious. Plasma physicists there clung to established models, pointing out the obvious. Atlas lacked a molten, churning core. Without that, there was no dynamo, no magnetic shield, no way to generate a planetary-scale field. The anomaly, they argued, had to be an illusion of physics, a case of induced magnetism. When solar wind slams into outgassing material from a comet, it can create thin plasma sheaths. These ghostly halos sometimes mimic the shape of a magnetic bubble, but they're fleeting, fragile, and nowhere near powerful enough to carve a bow shock like Earth's magnetosphere. For JPL, the simplest explanation was that Atlas's composition amplified this effect in an extreme, one-off case. Statistical fluke, not revolution. Not everyone would buy into that. Over at MIT, however, a rather different theory was afloat in the form of a draft paper proposing that Atlas might have collected a magnetized shell somewhere during its interstellar travels. Picture a comet as it drifts through the edge of a shockwave from a supernova long since past. Picture that surface infused with those remnant magnetic fields. An Atlas would, much like a sponge, soak up that memory through the whole of the cosmos and carry it into the solar system. Under the right kind of conditions with the solar wind, the theory went, a shell of that sort might, at least for brief periods of time, act like a true magnetosphere. It was bold, even poetic. The problem was that the math required field strengths far above those measured in similar objects. The peer reviewers pounced, too speculative, too dependent on assumptions, too convenient. But the idea would not die. The clash has spilled beyond laboratories. Certainly, the leaks that emerged online from peer review boards showed how harsh the bartering was. Some reviewers dismissed exotic theories as science fiction. Others accused conservative voices of being willfully blind to new physics. Slack channels lit up with arguments that blurred the line between professional rigor and personal disbelief. For every calculation that tried to fit Atlas into the old models, another suggested it might represent something entirely new. What this debate ultimately brought out was a deeper truth. No one had an answer satisfying enough to be held up as a mechanism by which a comet-sized object might bend solar wind like a planet. The more data was analyzed, the wider the gap between observation and theory became. Either Atlas was rewriting the textbooks, simply exposing the blind spots of an existing interpretation of anomalies. Outside the bounds of academia, the world was not waiting for consensus. There were rumors flying around, some even whispering about alien intelligence and others about hidden natural forces. But the real surprise wasn't going to come from a government laboratory or a think tank in a university. It would come instead from backyards and rooftops all over the world. While experts argued in closed circles, amateur astronomers began capturing images that would push the mystery into the public's hands. The amateur astronomers' evidence. While experts clashed in conference rooms and peer review forums, the skies themselves refused to wait. On July 3rd, veteran backyard observer Michael Matthias set his telescope toward 3IATL-AS. Known in comet-watching circles for catching faint outbursts before the professionals, Matthias wasn't looking for anomalies. He simply wanted a clean sequence of images, but what he captured ignited a firestorm that even NASA couldn't contain. In his raw frames, the ion tail of Atlas didn't behave the way comet tails should. Instead of streaming steadily away from the sun, it flicked sharply, almost as if jolted by an invisible hand. Within less than an hour, the orientation shifted by several degrees, accompanied by a sudden dip and surge in brightness. Matthias carefully logged the details, the filters, exposure times, and exact sky conditions. His photometry showed irregularities too abrupt to chalk up to noise. The data suggested the comet wasn't just reacting to solar wind, it was resisting it. Such findings were posted online in an astronomy forum, attaching processed images, the raw FITS files, and a time-lapse collage from images taken from his backyard. And in no time, replies poured in. Amateurs from Brazil, Hungary, New Zealand, and a few others brought their data into comparison with what Matthias has. Some confirmed the erratic flick of the tail, others saw nothing unusual, initiating heated debates about calibration, equipment quality, and atmospheric interference. But it was open, transparent, and global. Every frame and timestamp was open to scrutiny. Matthias's reputation lent weight to the claims, and soon enough, professionals began lurking in the thread. A few even messaged him privately, requesting calibration logs, weather conditions, and exact filter specs. Matthias obliged, sharing everything down to the humidity levels and telescope alignment. "I trust my photometry," he wrote, but NASA's spectral analysis goes much deeper. I don't see evidence yet for a fake, just a puzzle. His words echoed the spirit of curiosity that fuels both professionals and hobbyists. The cosmos doesn't care about job titles. The closest thing to the online frenzy was the talk on social media. Even trending hashtags added to the YouTube breakdowns and the mainstream media, which reporters echoed apart from NASA's official statements, from the backyard astronomers who might have spotted Atlas bending solar wind in real time. Calls for the open data people grew tenfold. They wanted to see the magnetic anomaly not through NASA's classified logs, but through amateur lenses. For years, the barrier between professional science and public participation was blurred.
Listen, we can't find another explanation. So this very well could be the clearest sign of life that we've ever found on Mars.
Only a telescope and dedication were required to tease apart the enigma. The democratization of discovery rattled the establishment. NASA thrives on careful calibration and peer review and cautious interpretation. But here came amateurs, armed with passion and relatively modest equipment, taking images to propound theories that one could hardly dismiss. At a time when one could see launches via streaming, when citizen scientists could help with apps, Atlas coalesced everything from fiefdom to scandal. Suddenly, discovery seemed collective. Yet amateur data could only go so far. Although intriguing, it did not carry the resolution of magnetometers and plasma detectors. If anything, the professionals kept the secret to the real answers. However, there were so many more independent reports along the way that these were all chips in the high-pressure game. With each erratic flick of the tail, with each photometric dip, something rare was gaining weight in the conscience of the astronomy community. And just how to consider the dimension of this Atlas anomaly. The community went back. Had this sort of mystery ever cropped up before? Was Atlas unique, or one more in the series of cosmic puzzles we have never solved? And that's when the echoes of past anomalies, Oumuamua, Ulysses, Voyager, came rushing back into the conversation, demanding comparisons that scientists could no longer avoid. Echoes of past anomalies. When 3I, Atlas, made headlines, many called it unprecedented.
I-3 Atlas. It was spotted just the other day on the 1st of July by Atlas, which spots new...
But for those with long memories in space science, it felt more like déjà vu. Atlas wasn't the first visitor to challenge the rulebook, it was just the loudest. Over the decades, space has offered riddles that never quite fit the equations. Each one left a scar in the data, a lingering reminder that our understanding of the cosmos is far from complete. The most famous came in 2017, when Oumuamua streaked through the solar system. Unlike Atlas, Oumuamua showed no signs of a magnetic field, but it delivered its own impossibility. Astronomers watched as the object accelerated as it left the inner solar system, without jets, without a tail, without any visible propulsion. Some argued radiation pressure from sunlight might explain it, others hinted at exotic forces, or even technology. The debate was never fully settled. Even today, Oumuamua remains a case study in how interstellar visitors can defy expectations, and how fragile our explanations can be when the evidence doesn't cooperate. Further rewind to the year 1994. The Ulysses probe was soaring high above the poles of the Sun and recorded a sudden and sharp decrease in the magnitude of the solar wind's magnetic field, followed by an almost equally severe increase. After months of analysis, no explanation could be put forward. An instrumental artifact, a rare solar event, or did Ulysses skim past some hidden structure of the solar wind itself? The logs were filed away, marked as an unsolved curiosity without ever being explained. To this present day, that entry lingers in the mission archive, continuously reminding investigators that not every anomaly is laid to rest. Eventually, they reached Voyager 2. Its instruments detected invisible walls while approaching the heliosphere, a bubble shaped by solar wind. Boundaries that shouldn't have existed were observed where particle density and magnetic field strength changed suddenly. The spacecraft was now in regions where the rules could turn out to be something else, with no advance warning. Scientists scoured their models, but were unable to find one that completely explained the bizarre behaviors of the unknown boundaries. Some of these readings would go down in history as some of the oddest ever accomplished by Voyager. This mystery is slightly dimmed by the distance and the age of the spacecraft. Each of these events, Oumuamua, Ulysses, Voyager, has forced astronomers to take a step back and reconsider their governing framework. They did not provide easy solutions. They did not resolve any case. Rather, they became fodder for the next generation of instruments, the next wave of missions, the next desperate attempt to measure what had before slipped away from us. Well, Atlas, with its supposed magnetic deflection of solar wind, now joins the list. The echoes of these peculiarities are significantly greater than their scientific aspects. They shape policy and its allocation and create ambition. Following the introduction of Oumuamua, NASA had to face Congress's more specific inquiries about the unexplained mysteries of space. Budgets have been realigned and new investments made in magnetometers, and new plasma detectors have been approved. Each unexplained event becomes another leverage for bigger missions with sharper tools planned to be braved. The cosmos, in all its strangeness, helps to improve people, not through comfort, but confrontation with the unknown. The cosmos has always tested our limits, but 3IATLAS may be the boldest test yet. NASA admits the evidence is real, but the meaning is still hidden. Is this a new force, an alien relic, or a glimpse of physics we've yet to discover? What do you think Atlas truly represents? Share your thoughts in the comments. Don't forget to like, subscribe, and watch the next video on your screen for more mysteries shaping our cosmic neighborhood.